In this portion of the PPST, we will look at quantitative data and their displays. One display is called the bar graph, and it has categories that represent either horizontal or vertical bars, as well as the frequency in which those categories appear. Therefore, in this bar graph, we can see that 12 students, and we could find the total number of students by taking 12 plus 10 plus 6 plus 2 gives us a total of 30 students. Therefore, 12 out of 30, which is 4/10 or 2/5, which is also 40%. 40% of our students selected the dog as their favorite pet. Another representation is the pie chart, which breaks our whole into percentages. We can see that 20% of our students liked fish, and since we know there were 30 students, we could find 20% of 30 as 0.2 or 2/10 times 30, which gives us 6 students that had fish as their favorite pet. Pictographs use pictures or icons to display data. For example, if I know that one face equals 20 students, then the number of students at this Longfellow Middle School that take the bus can be represented as 20, 40, 60, 80, and then half of 20 or 10, which would be 90 sixth graders ride the bus at Longfellow. Line graphs are another useful tool that measure or show change over time. In this case, we have the number of students enrolled in a certain school district. We can see that in 1980, there's about 900 students. In the year 2010, there was a little over 1,800 students. Therefore, the enrollment in 2010 was approximately twice that in 1980. Histograms are another way to look at frequency where the bars are clumped together, giving us ranges instead of actual categories. Therefore, if we want to know how many snacks had a range between 80 and 90 calories, we could see that there were 10 of those snacks. Stem and leaf plots are another way in order to represent the data. In a stem and leaf plot, the leaves are our last digit and our stems are our other digits. In this case, if we're looking at temperature, 68 degrees would have a stem of 6 and a leaf of 8. Therefore, this 7 represents 70, and this shows us that the temperature of 78 appeared twice. This 10 would stand for 10 tens or 100. Therefore, one of our temperature was 103. Notice that the key in a stem and leaf plot is useful to help us determine what that measurements actually stand for. A scatter plot looks at a way to compare two data points of a particular person or some related object. For example, our scattered plot looks at a person's height and a person's weight and plots them as ordered pairs. Therefore, we have one individual that has a height of 50 inches and a corresponding weight of 100 pounds. We could create a line of best fit to predict this positive relationship between height and weight. For example, if we wanted to know a 60-inch person, how much they weighed, we could use that line to say they weigh about 125 pounds. Finally, on the PPST, we'll be asked to match graphs with their data set. Here we have a bar graph, and we know that the number of students whose favorite subject is physical education is 5, language arts is 7, science is 10, history 12, and mathematics is 14. We want to know which of the following bar graphs is correct. Well, in this bar graph, it says the number of students that liked physical education was 14, which is incorrect. Therefore, we could see that it has to be that second bar graph. Mathematics of 14, science of 10, history of 12, language art of 7, and physical education as 5.